global economy and after the pandemic environment, it's a huge turbulence in the economy is there. And the highest priority, any country or any nations or any political leader, is the topmost priority is energy securities, which is extremely important for our nation also because we are extremely vulnerable and unsustainable economy environment. So that is becoming a very, very things. And now the world also has, after the COP26, most of the country has agreed to reduce the carbon footprint and decarbonization focus, which is the first time has happened in the last 25 or 30 years. And it's now as per the UN, it is clearly declared as a climate emergency. It's not just we are producing renewable energy to reduce the cost of energy, but it is more on survival or sustainability of the global economy and our country economy. Not only that, we have observed in the last 12 months, there is a energy emergency also. It's a new thing has emerged because the developed nation is passing through the lot of difficulties in an energy security point of view. And it is an energy emergency. The environments are happening very, very strongly. Recently, if you see the Hungary and also recently in the South Africa, it's a completely blackout situations are happening because the whole ecosystem of the energy portfolio is completely disturbed after the geopolitical issues because of that. And that is continuously hampering the economic growth of the developed economy, and that is impacting, and we have observed the developed economy is passing through 7.5% inflation rate, which never in last 30, 40, 50 years they have observed like this, because it's not the case in the economy. So impact will come to India huge way. We cannot underestimate because the impact comes after 6 months, 9 months or 1 year, not immediately. So we have to prepare our situations and we have to mitigate. We have seen across the value chain areas, whether it is a food price, a crude oil, whether it is a shipping price in every area, the price is increasing and it is continuously impacting the inflations. And now gradually the world is moving on a recession zone. It's a very, very clear conclusion is coming out. Okay, after pandemic, what is this disturbance is affecting and how and what way we can mitigate this crisis for our country is extremely important. By 2047, why 47? Because we are completing 100 years, 2047. The biggest thing is our populations. The 1.4 billion will go 1.6 and by 2070, 2 billion populations. I think that is the biggest, the risk is increasing. The climate risk anyway is there, it is affecting huge impact on our drinking waters and also the agriculture foods and affecting the life or health of the people. And it is deteriorating in a year on year on year. We are not feeling immediately, but it's a very slow poison process is going. So in nutshell, once we say the very limited resource, the huge populations and the climate risk, our economy is not sustainable. It is a very, very clear indication is there whether we believe we are going very well, we are not going in the right directions. We have to find out solution today for our survival of 2047 or 2050. Now what is the economic impact is coming? If we can observe and everything is there, the import is increasing, our export is not sustaining in that. Our interest cost is increasing, inflation is increasing, and the industrial, the power consumption load is not sustainable, nature situations are there. So whatever the capacity we have built on a coal basis, and now the cost of coal and cost of coal-based power production is almost 6 rupees 50 paisa, where against the renewable energy is providing is a level of 3 or 3.5 rupees. So it's a huge 50% difference on that. So it's not a sustainable the economic model for the survival of the company or country. So economy is not sustainable is the clear indication and conclusion is coming day by day. If you see the 1.5 year before what was the rupee and dollar, the rate was there, and how much today we are observing. Why such an impact is continuously doing? Because directly, indirect, we are deteriorating. It's the reality, and that is the situation we have to understand. Let me understand that last year our import bill of the oil was just 62 billion, and today is almost double within a 1 year. Whether we have done the double economic growth? Answer is no. But cost of oil has gone high and currency rate has gone high. Both put together, it is a drain of $60 billion from our systems. So it is a huge economic losses is increasing. The same why is the fertilizer subsidy. Because we are importing a lot of the required raw materials or the liquid fuels for our chemical plants or fertilizer plant. We cannot pass on to our farmers, and because of that, that also has gone the double. So it's a huge drain of our liquidity is moving from country to other part of the world, and which is not bringing the sustainability. Our financial cost will go high, our inflation will be difficult situations, and our currency will more and more deteriorate. So these are the real situations are there, whether we like it or not liking, and we are facing. And when we see our 2/3 populations cannot afford this, that is the reality is there. Maybe we are living in a different part, that's fine, but 2/3 is not living in the same situations. Now, what is our energy demand will go in a going? Today is already 400 and we are facing even coming winter, maybe we see the crisis situations will come. We have to also face on that level of things. So we are not yet fully sustainable on our power portfolio, and most of our energy and fuel like oil and other gas and other 90% we are imported. So any fluctuation of the global economy market or geopolitical disturbance, it's make extremely vulnerable for our nations. It's not thing. So almost 4 times it will go. 1,600 gigawatt is required, but that is only electricity required. Once we start using electricity to produce the fuel, then another 800 gigawatt is required. So the total is a 2,400 gigawatt capacity is required by 2050. So it's a huge, because our per capita energy consumptions will increase, our populations will increase, our industrializations will increase. So it will need is there. We have to ask whether we have a sufficient source of resource and energy and everything. Yes, we are only depend on import. It will not bring us our sustainable economy. It is a very good initiative taken by our prime ministers, right? Panchamrit in Gujarati is a Panchamrit is a 5 elements together. It makes the spiritual or holistic result. So these are really things. 500 gigawatts we have to produce. We have to reduce our carbon footprint by the 50%, and by 2030 we have to bring more and more renewable capacity, so that our dependency on import can be reduced and we become a more and more truly Atmanirbhar focus area, and that is creating an enormous opportunity for industries, right? Cake of the industries is such a large, you cannot believe like that. There is a space for so many companies and so many startups, so many young generations can be accommodated in these sectors. If we can certain things fix up and understand the country's economy and country's life survival issues, it's not a need of just energy. And if we can drive the economic situations and policy framework, it will change is there. Now 175 gigawatt we are targeting, almost we are 160s are in a pipeline and completing. When the announcement was there, we are not believing, but this is not enough. Even 1,200 gigawatt is not enough. Just imagine, as per the 2070, our target as per the UN commitment, net zero. If you want to achieve net zero, what is the energy required? 5,000 gigawatt energy of renewable required. 1,700 is a wind, and 3,500 gigawatt. That means from now every years we have to add 100 gigawatt minimum. $100 billion investment is required. So it's not a small target for the nations. Then and then only our survival. It's not we are achieving something and we become a stronger and everything, but just we can survive. So it is a huge requirement of the capacities there. Now it's up to us as an industries, how and what way we can convert this opportunity rather than killing each other and fighting each other. There is a huge size of cake is there for all of us. We have to build nation in a long-term sustainability focus area rather than the killing each other approach and everything. So our competition is oil and coal. Our competition is not within the renewables. We have to need every source of renewables cannot able to achieve 5,000 gigawatt. So we have to use whether we like it or not like it. So we have to go in every corner of the world, India, and to harness this energy as much as that. It will solve our enormous problem, not just the energy requirement. But same time, we cannot build the power sectors or our energy sectors, whether it is for electricity, whether it is a green fuel, based on import, because that is another poison for our country is there. We are already importing $120 billion oil, and top of that we want to import the capex for investment, which we have to do every year $100 billion. We have a capability, we have engineers, we have a manufacturing expertise. We should not go on a short-term gain approach, we import and make fastest money. Forget it. Let's build the really large capacity in the country. We need a 50 gigawatt solar manufacturing capacity in the country and 20 gigawatt the wind capacity in the country. Then only 70 gigawatt happen. We need 100 gigawatt per year. So we have to build the large capacity. We have to invite most of the global company to come and establish their shops or joint venture or technology partners and anything. So that really, truly, in a sense, Atmanirbhar Bharat we should build, not on a import, because import is a real poison for our economy. And that is already we are suffering. 40 years before, I know the 8 rupees dollar was there and today 80, right? And it will happen when 2050, it will be 200. Whether we want to go that way or whether we want to go $40. So we have to think for our economy sustainability, not just the need of the power. We have an event in 17, 18, 19 in Asoka Hotel of this Atmanirbhar Bharat of first annual event. I would like to invite you to join, all of you. It's really good how and what way we can unlock the manufacturing potentiality capacity in our country. Now, what is the energy transitions when we are talking is a very clear is a renewable energy, which wind and solar we are doing. Then another is now next phase is coming for the next 25 is a green fuel. Green ammonia, green hydrogen, green methane. And that is our future because $120 billion bill, and by 2050, it's a $300 billion bill of import of oil. We want to close that. We have to kill that. And that through wind and solar renewable capacities. It is achievable and more affordable and sustainable, and we can hedge the fuel cost for next 25 years. Today, when we are signing 25 years PPA, that means my power cost will be remain fixed for 25 years. But nobody is signing today oil contract for next 25 at $60 barrel. Nobody will sign. So we want to bring for our country how we can make from renewable energy the fuel. That is another 800 gigawatt capacity is required to build this capacity for 2050. But if we go to the 2070, it is a required almost 2.5 gigawatt to wind and solar capacity to convert into the fuel. So, and energy efficiency, because we are quite weak on this area, where we have to guide and educate our consumers how and what way to utilize this, the precious energy in such a manner so that we cannot require more requirement. Now, this is the next future of our the industries, our country, and for the world. So wind and solar, which is a natural resources and water. Through the electrolyzer, we can convert into hydrogen. And from hydrogen, by adding the carbon, we can produce the methane. By adding the nitrogen, we can produce the ammonia. Each and every our energy requirement is absolutely satisfied. Hydrogen can be utilized for the steel, cement, and heavy industries and petrochemicals we can use directly. We don't require to import the coal or oil or anything on that front. All our mobility, car will go in the battery systems, but trucks go on hydrogen, ships goes on ammonia, aircraft goes on ammonia. So we can work on this way. So we don't require to import anything, and this is a fixed price because what is the cost of material? It is our financial cost or capex cost. What you are today doing a PPA for 25 years. Now next phase of 25 years, the PPA for the green fuel will come. So these will completely change our economics foundations. And that is the focus area, is that it's not just we are bringing energy to make a green, but we want to make country's economy stable, sustainable, and long aspect it is a thing. Now what is a green fuel trajectories which is planned? It's still small target is there, but it will go beyond that. The 6 million ton hydrogen we are targeting by 2030. 6 million ton into 25, so that means 150 gigawatt is required. Additional capacity to produce this hydrogen. This is the way the 30 gigawatt is almost 750 or 800 gigawatt is required by 2050. The same is an ammonia. Why it is ammonia? Ammonia is a carrier. How to mobilize electrons from one country to another country? Hydrogen is not economically viable to transfer one country to another country, because to convert into the hydrogen fuel and 253 degree minus temperature, logistic is not established in the world. 20 million ton ammonia is already, logistic is happening today in the world. So this is the way. 170 ports, the infrastructures are available, 140 ships are available. So we can immediately leverage that to transfer electrons one part to other part. It's not required today. Electricity, what we are producing, we are facing difficulty, sometimes lower pricing and lower things. We have to change our mindset. If it is a lower, let's we produce and export in other part of the world, right? The Europe is heavily interested to buy our fuels from India, and Japan and Korea, and those markets are available, and whatever tariff and pricing you are selling, you will get double the pricing easily, and still export will happen, which is benefit to the nation. Because we are importing a lot of fuels, and against that we are exporting, we can, natural hedging can be start. So this is our future for our sector. How and what way we can go 5,000 gigawatt by 2070. We are talking 160 gigawatt is there, and we are struggling and fighting. Neither stable uniform policy frameworks are there, neither our ecosystem is good, is there, neither as a industries we are working together. It's a different things. It's a huge opportunity and space is waiting for us. How world is looking India? It's a very clear, India is a manufacturing hub for the world, because world need an alternate supply chain. And where is the alternate supply chain is possible? Only India. So whatever manufacturing capacity, not just for the domestic market, but the global market, 190 country has signed the agreement in a ISA, the International Solar Alliance. So we have that large market opportunity. So we have to go in a technology development, supply chain development, manufacturing, service provider, project execution capabilities, not just Indian market. Indian market in the world is a 5%. 95% markets available for India. Because if we are really cost competitive, 2 rupees 50 paisa or 3 rupees, if we can able to produce power in India, other part, they are very comfortable with 4 rupees, 5 rupees also, and 5%, 4% interest cost. So there is no harm to go in other territory rather than struggling and fighting in the Indian market situations. So by 2047, industries we are targeting, let's we become a net exporter of energy. Today we are continuously importing, with $300 billion will happen 2050. Now let's we go in 2050, how to export $300 billion energy from India, so that it is a net effect is coming out. And for that it is a required almost 2,500 gigawatt capacity by 2050 to make that happen, domestic demand plus fuel demand. And by 2070, our Prime Minister has already set target as industries we should try to bring earlier. Because we are the only country in the world is 2070. Most of the country is between 2050 to 2070. So we can try to bring by 2047, where truly our independence, after 100 years we can achieve. Then and then only our 2 billion population of future will survive and sustain, otherwise not. Because energy security, water security, and food security is the solution, is the renewables. It's not just fuel. So this is the ecosystems are important. So renewable cannot give you just the power, but it will take care of the water requirement. The Gujarat, Rajasthan, and Tamil Nadu already passing through the water crisis today. By 2050, all India will be there. In that situations, the renewable can useful for desalination plant to produce the drinking water, and for irrigation purpose, we can utilize. It's a very good ecosystem. We can affordable water can be managed. When the real crisis will start, we can be equipped. The second is the food is there, because by 2040, almost 35% of our site or land will not useful because of water. Either it is because of the condition of the temperature and other thing, we cannot able to produce the food. And same time, our population is growing. So we have to address that. You will be surprised today, 1/3 glacier of Himalaya we have already lost. And by 2050, 2/3 glacier will be out. So it will be disaster ecosystem is happening. Now we are not doing a just business. We are working for our next generation and making so sustainable world. And that contribution is the biggest contribution for each and every individuals are contributing today in these sectors. By bringing up these 4-5 things, the energy securities and bringing our interest cost goes down, more and more renewables, our inflation goes down, our currency will become stronger, our export will increase, and finally, end of the day, is our long-term sustainable economy, and it's create enormous sustainable jobs for the next 25 years or 50 years. So this is a really sector can turn around our economic situations rather than struggling the life in the country. So what we all can able to do? Let's we take a pledge today, and we should demand for our utility or our supplier, only renewable energy we consume and only green fuel we should consume. That should be our motto, and we should be a brand ambassador in the country to make sure that happens. So thank you very much. Thanks for your time.
Can we have somebody from the audiovisual onto the stage, please? Thank you so much, sir. Ladies and gentlemen, we've been very fortunate to hear it from the expert, the stalwart from the field, Shri Tulsi Tanti. Thank you once again, sir, for sharing your insight with us. We have yet another power-packed experience and thoughts being shared, yet another stalwart from the industry. Ladies and gentlemen, please put your hands together as I invite the President PB Manufacturing, Reliance New Energy Solar, Dr. Milind Kulkarni, onto the stage. May I request you, sir, to kindly come and join us onto the stage, share your insights and your thoughts, your experience and your vision with us. Can we all put our hands together as we welcome Dr. Milind Kulkarni?
So how would I move it up? Slides. How will I move the slides up and down? I don't. Okay, and how will I go back? Okay. Switch it out. Okay. Thank you. Thank you very much. It is very difficult, practically impossible to follow Mr. Tulsi Tanti. That was an outstanding job. While I think that actually I should thank the organizers and Informa for inviting me here to give my presentation, I'm not so sure whether actually I should do that because they asked me to follow Mr. Tanti. Nobody looks good after following him, and that was an outstanding, comprehensive presentation. And I do remember working with Mr. Tanti for 4 years. I feel fortunate to have had that opportunity to work with him. And I also fondly remember so many passionate discussions, arguments, debates actually we had. Some of these debates were so heated, we generated enough renewable energy to light few villages. Just like solar and wind, Thankfully, they were intermittent. But all jokes apart, actually, those were extremely actually good times. Talking about exciting times, we are living through exciting actually times here. And I believe we are living through energy revolution. That is basically what I want to actually talk about. How to enable this overall energy revolution on the platform of solar energy. Obviously, there are going to be various components contributing to this revolution, but my focus is going to be on solar energy today. I will talk about various technology platforms that are enabling this, value drivers that allow differentiation for various players, and how the future roadmap looks for the solar energy. Once again, I want to actually make an emphatic statement, very ambitious, but not to this audience. It looks ambitious to the outside world. We are living through two industrial revolutions. One is the digital revolution, which everybody can relate to because it is affecting the way we live. But other one is the energy revolution. It is like a tsunami. It is beneath the surface, but its impact is going to be huge. Obviously, people who are working in renewable industry understand this, but the larger population still has not internalized this. All of you know that if you really ignore the temporary increases in actually polysilicon prices and module prices because of various reasons, cost of producing solar energy at DC level has come down to 3 cents or less than 3 cents per kilowatt hour. And I want to make a case to you that on the same technology platforms that we have, this cost is going to further decrease. This is a low-risk decrease we are going to see. What is the most important thing we need for this solution is not necessarily actually this improvement in power generation cost, which is important and that is going to happen anyway. Solution to intermittency. We need significant actually technology improvement and cost reduction in our energy storage solution. It is already happening. It is not the question of if, it is just the question of when. In future, we can have AC level, round the clock actually power at around 5 to 6 cents per kilowatt hour. That is going to actually change the game. So in the long run, anyway, there are various projections. I'm not an exception here. More than 80%, 85% of our energy needs will be met by renewable energy. And solar energy is going to contribute significantly to this mix, as Mr. Tanti mentioned. Bottom line is that the way we consume energy, the way we live is changing. These are not common opportunities. We are actually living through industrial revolution. To understand this, let us actually take a look at two charts that you have already actually seen. First chart shows you how module cost has dropped down from 1976 to present times, all the way from more than $100 per watt to 22 cents. As I said, forget about the temporary actually spike because of increase in polysilicon actually prices, which is the result of supply-demand imbalance, and we are facing some logistics and supply chain issues also. But before all these actually fluctuations hit us, modules in China were selling at around 22 cents. This is the selling price. This is not the manufacturing cost. So they were selling at around 22 cents per watt peak. And if you look at what has happened from 2006, rate of this cost drop has increased. What happened in 2006? Chinese entered solar market in a big way. There were economies of scale, there were economies of learning. Because of that, module prices started actually dropping down. This also meant that the cost of solar energy also dropped quite dramatically. The second chart tells you a big story. It gives you LCOE, which is essentially the cost of actually energy for various sources. Solar energy, just 10 years ago, used to be among the most expensive sources of energy. Today, it is the cheapest at the DC level. So what has happened? First of all, whether technology platform can enable this is the first question. But no sector actually should see this kind of actually change in a span of 10 years. It does not happen unless there are some specific and unique reasons. So we have to ask that question, how such a dramatic actually change in solar energy actually cost and performance and efficiency happened in such a short period? Answer is quite simple. Solar value chain is an adaptation of very mature semiconductor silicon value chain. There was no reason to reinvent the wheel. There was no reason to reinvent technology platforms. It was simply the question of adapting more than 50, 60-year-old silicon technology platform to solar needs. That really has accelerated this progress in solar sector. To understand this, let us take a look at semiconductor value chain. I'm only actually talking about making semiconductor substrates here because that is the most relevant technology platform we are talking about. Semiconductor value chain starts with making polysilicon. You first actually produce silicon containing gases such as TCS, trichlorosilane, or in some cases silane from metallurgical grade silicon. Then extract pure silicon from these silicon containing gases in specialized reactors such as Siemens reactor or fluidized bed reactor by chemical vapor deposition. This polysilicon is then melted in quartz crucible and single crystals are grown. And in semiconductor industry, nanoscale defects that evolve are engineered actually quite intelligently, which is very specific to the semiconductor industry. But the story is that actually you are growing single crystal from silicon melt. This cylindrical actually crystal then is sliced into multiple circular round wafers by a process called slurry slicing. This is the wire saw process. In this process, both mechanical and hydrodynamic forces are used. But this is a very well established technology, and you make wafers this way. And these wafers then go through series of chemical and mechanical and chemical-mechanical unit operations. Chemical operations involve caustic etching, acid etching, various actually chemical cleaning processes. Then there is the chemical-mechanical polishing that actually renders the surface of each silicon wafer specular at the atomic level, which is required. And defect-engineered wafers can be directly sold to some customers. But some customers like Intel require deposition of additional defect-free layer of silicon on top of the silicon wafer. It is called silicon epitaxy. It is essentially deposition of silicon by chemical vapor deposition by another set of specialized reactors on top of this silicon surface. Now, new composite actually substrate known as silicon on insulator is becoming popular. I will not go into details of this, but it is important for us to know that production of this substrate involves ion implantation, growth of these ions to create actually separation layers, and layer separation, which becomes important for some of the technologies we are going to talk about in the solar industry. We don't have to really actually go into too many details. Just we have to actually now look at solar sector. In the present state of the art actually solar value chain, polysilicon is produced the same way it was produced in the semiconductor industry. Polysilicon production is more than actually 50-year-old technology when you talk about a Siemens platform. Fluidized bed reactor technology is more than 30, 35 years old. Polysilicon is produced the same way in the solar sector. Polysilicon is melted and single crystal is grown the same way in the solar value chain. Now, this cylindrical ingot or crystal is then mechanically sliced into square brick, which is a very, very simple process. And the square brick is once again sliced into multiple actually square solar wafers by wire saw process. Only difference here is that instead of slurry slicing, which uses both mechanical and hydrodynamic forces, diamond coated wire uses basically actually mechanical force. So it is essentially identical. Now, cell making is also actually really no different. I mean, today actually PERC cells are actually dominating the industry. These cells are essentially diodes. Then obviously actually the future actually cells such as heterojunction and topcons are actually, topcon architecture are also becoming popular. But in making cells, the unit operations involved are very similar to actually what have been developed in the semiconductor industry. Texture etching is very well established in the semiconductor industry. The most important process in the manufacture of cells is PECVD process, which is very well established in the semiconductor industry. So I would like to make a case that really at the fundamental level, there isn't actually anything new happening in the solar industry. I'm not saying creative things are not happening. I'm not saying innovation is not happening. But we have to take a step back and look at the fundamentals. It is the application of a mature industry. And some of these ideas were already actually existing in the semiconductor industry, but they were not relevant for a semiconductor application. And one of actually that big sets is simply the cost reduction, right? So we are looking at a very, very interesting phenomenon here. Everybody actually who does strategy or studies strategy knows that all sectors goes through so-called S-curve. This is called maturity versus time curve. When a sector starts independently on its own, at a very conceptual level, rate of learning is going to be slow. There is going to be a lot of trial and error. There will be no economies of scale. So improvement is going to be extremely slow. But as people start seeing light at the end of the tunnel, more and more people who take risk enter the market. There is more investment that comes in. There will be economies of scale. Economies of scale are associated with economies of learning. Then you basically start seeing improvement in maturity, improvement in performance, improvement in efficiency, operational efficiency, research efficiency. That is the inflection point. Now we actually push this sector to the limit, then the rate of improvement actually goes down. And some sectors really die out also. They actually just ride this S-curve and actually they die out. But semiconductor industry is nowhere close to dying. This is a silicon industry. Even at this level of maturity, it is growing at around 6 to 7% every year. Moore's law still holds. Computational capacity of integrated circuits is doubling every 18 months. But it is still a slow growth compared to the solar industry. Now, realistically speaking, at around 2006, when Chinese entered this market in a big way and adopted all the technologies available globally, started developing indigenous actually technologies also. Sorry, it's not working. Okay. Now we see this red curve, which is the second S-curve. That is the solar silicon S-curve. You can see that this S-curve is actually shorter. Its acceleration is higher because it was built on the platform of the semiconductor industry. At least in my view, this is pretty unique. This is what is enabling this energy revolution. Because I lived through this industry. I was tired of actually making more and more modest projections myself regarding cost reduction and efficiency improvement. There hasn't been a single analyst in this industry who has been right. Industry has beaten everybody's projection in the positive direction. Realized costs were lower, realized efficiencies were higher. Because people started using standard actually methodology in projecting the future. Nobody took into account that this is a completely different game where we are essentially leveraging mature platform to realize the future. This is why it is exciting. This is revolution on steroids. So this definitely actually personally excites me. So we have to ask the big question now. With all this cost reduction, where is the limit? Are we done? Going from more than $100 per watt to 22 cents looks like a big jump. Are we done? Answer is no. Even on the same platform, there are significant evolutionary opportunities. I also submit a case to you. We really actually don't need any new technologies to evolve in solar generation. significant actually improvement is required in energy storage. But as far as solar generation is concerned, the present technology itself is capable of actually giving us significant cost reduction. So that is exciting, but on top of it, actually, there are revolutionary opportunities. I briefly want to actually talk about them before I conclude. What is happening in polysilicon? The present state of the art technology is Siemens. Already, actually, cost of polysilicon has actually come down significantly. And this technology is going to prevail for some period of time. Fluidized bed reactor technology is already established, but it is protected technology. It will not proliferate because this complex technology is not available for licensing. But as a sector, this option is actually available over a midterm and long term. In crystal growth, industry has moved from multi-crystal growth to single crystal growth, from single batch process to multi-batch Zakralowski, which is known as the Richard Zakralowski, in which you grow around 5 to 6 crystals per cycle. That will evolve into continuous Zakralowski, which will further reduce the cost and also improve quality. As far as slicing is concerned, not much needs to happen anyway, quite frankly. Diamond-coated wire process is pretty robust, extremely low cost, very stable. But now what is happening in the long term in these three sectors? There are quite a few new technologies that are emerging. Some of them have extremely high risk. One of them is the direct wafer technology, where you can make single crystal wafers directly from silicon substrate. Thus, you don't have to make polysilicon by CVD, don't have to grow crystal by the Zakralowski process, don't have to slice the wafer. But this technology, which is the direct wafer technology, is technically feasible, but whether it is going to be commercially viable or not still remains to be seen. And this idea is pretty old, by the way. But anyway, this technology is in the pipeline. And there are quite a few other concepts I cannot actually speak about because of the proprietary reasons, but they are also in the pipeline. As far as cells are concerned, we all know PERC is the workhorse, and most definitely heterojunction and TOPCon and architecture are emerging. High efficiency alternatives are coming. It's simply the question of capex reduction. It is simply the question of optimization that reduces the variable cost. So path is very clear. Exactly actually how much market share these two technologies will gain as a function of time is debatable, but they will gain because they are going to offer lower LCOE than PERC is offering. But beyond that, the most exciting research that is going on, but it is a high-risk research, is on perovskites. As all of you know, perovskites are organometal halides whose optical and semiconductor properties can be manipulated by adding actually different impurities. And if you make a tandem of perovskite and silicon cell, you can really actually use most of the solar spectrum, which silicon cannot, because of its actually bandwidth. So you can really actually achieve 30 to 33% actually efficiency by silicon perovskite tandems. That is going to be a completely game changer. But we really actually don't need it for us to still actually realize our energy revolution goals. That is how attractive this situation is. The present technology platforms have not matured yet from solar point of view. And I will give you approximate numbers. It also depends on geography. At the DC level, cost of making solar energy will definitely go down below 2 cents. It can actually even touch 1.5 cents per kilowatt hour over a long period of time, without having to lean on new technologies, just by evolutionary improvement. And improvements in energy storage are definitely happening. Those who have spent enough time in the solar industry know that there are many similarities in terms of cost reduction between assembly of cells into modules and actually how you actually put together cell and actually all other battery components. And if anybody says that these are all commodities, where is further room to actually decrease cost reduction? Just have to actually look at what happened to modules. Module is made of all commoditized elements other than silicon cell, which is also now is the commodity more or less. So scale is going to do wonders. The capex of actually lithium-ion battery will actually come down to $100 per kilowatt hour over a long period of time. Once again, question of when, not if. There are many other energy storage solutions available. And as Mr. Tanti actually discussed, green hydrogen and all these actually alternative solutions will enable the overall actually renewable energy revolution. Right? So with this actually, I just want to actually give you 3 important numbers. We talked about technology, we talked about the history of solar industry. Module cash cost, I'm not talking about the total cost. Module cash cost will hit 13 cents, maybe even 12 cents in next maybe actually 4 to 5 years, when the cost of making TOPCon and heterojunction cells actually comes down. That means modules will be selling perhaps at around 15 to 16 cents per watt. And these modules are going to be bifacial. That is a significant actually advantage that we will have in generation of energy. DC level LCOE, I'm being conservative when I say it is going to be 2 cents. It is going to actually touch 1.5 cents. So our LCOE is going to go down by 50%. Then we will have AC, RTC actually power at around 5 cents per kilowatt hour, right? And when I'm giving you these numbers, I'm not thinking of perovskites. I'm not actually thinking of direct wafer. I'm not thinking of technologies that are not in high volume manufacturing. I'm only thinking of TOPCon and heterojunction. And everything else is established technology, and there is a significant room. If these are not exciting times for you, then I think you are dead. Right? So any living person should be excited with this. With this, I would like to end my presentation. Okay? Thank you. What?
Thank you so much, sir. Thanks indeed, sir. We'll quickly take this moment to extend our heartfelt gratitude to you, sir. Not that it means a lot, but then it's a small token of memory from our side. May I request Mr. Amit Sharma to kindly join us onto the stage, the head of conference in Informa Market, to extend our heartfelt gratitude to Dr. Milind Kulkarni. Ladies and gentlemen, can we put our hands together as we thank the stalwart of our industry for sharing his vision, his experience with us, and most importantly, his time with us. Thank you so much. Ladies and gentlemen, we're very fortunate to have amongst us a very, very important person from the industry, yet another stalwart from the industry. Please put your hands together as I now invite the Vice Chairman and Managing Director, Enercon India, Senator Dr. P.K.C. Bose. Very warm welcome to you, sir. Very warm welcome to you, sir. Over to you. Thank you for sharing your time with us.
Thank you. No, I have one. Oh, yeah, the pointer is here. But there is a video film, so they have to drive that. But this is, can you tell me that this is? So this is the forward, and I think you have to press this to do that. Sorry. Yes, I'll tell you. So, good evening, ladies and gentlemen. It's a pleasure and honor to be here. So, Mr. Tanti has mentioned about the ecological and economy areas as an expert, and Dr. Kulkarni has mentioned about the future of photovoltaic and the solar. Let me take you through what are the innovations taking place in the wind energy sector. That's interesting for, I'm sure that all of you would be interested to know what is happening in the innovation. So there are 5 topics I'm going to touch base in the next 20 minutes time. The one is innovation and technology advancement in wind industry, India's journey in wind industry sector and challenges ahead, few recommendations, dream of net zero emission nation status by 2070, and also the wind energy and green hydrogen combination. In order to take it forward, let me first show you. If you look at traditional wind from 1858 to a 800 kilowatt gearless technology introduced in 1999. Since then, the technology innovation has been expanded rapidly, and the latest, while I'm talking to you today, I have the pleasure to share with you that at the same time, we just few minutes back unveiled the largest ever built onshore wind turbine of 6 megawatt in the Hamburg show. It's a totally gearless technology turbine, which has many, many advantages. So the technological innovation when we are talking about, number one is the commissioning and installation is one of the biggest challenge in the wind industry. So we have something called a climbing crane for easy installation of a wind tower. So may I have the video to play? Gentlemen, this is a 2 minutes video which I would like to present to you that how a climbing crane can make it a 168 meters of tower within 1 day's time. Thank you. So this is one of the innovations, whereas the second is the generator technology. The generator which we produce in India is 4.2 megawatt, and for now the 6 megawatt. India will be our global manufacturing hub under the Atmanirbhar Bharat program. This means we will be producing the entire 4.2 megawatt and 6 megawatt turbines, the generators. These generators are all modular generators which can be assembled very easily. and 85% of the components, we source it from India. So India, all the components are available except a few, which also should be available within next 1 year's time for us. So this is something which the gearless technology has its advantages. Of course, the gearless technology turbines has many advantages compared to the gearbox ones. So then coming to the hybrid fabrics for the lightweight blades. Now, when you look at the composite industry is growing in a very considerably in a very big way, especially in the aeronautical and also the wind side. So earlier people used to have the blades which are purely made out of the glass fiber. Now we have a hybrid which is a combination of glass and carbon. And interestingly, the spark cap is made out of carbon pultrusion, which is again very easy. You can even outsource that and also fix it in your turbine. The root, some of the parts are even made out of carbon fiber. So there is a huge change. So the outcome of these changes, you get cost-wise benefit, also you get much more stability and quality over a period of time. When you are offering a 25 years life cycle, this is one of the biggest advantages. Then I'm talking about the carbon composite for bigger blades. Now we are all talking about the offshore blades. So for an offshore blade, the biggest advantage is using the carbon fiber for the larger blades will be always beneficial. Of course, there is a cost involved. The cost is quite on the higher side. But I'm sure that we in India will also find in near future a lot of sources for carbon fiber, which I know that some of the companies in India are working extensively to produce carbon fiber locally. Maybe India will be one of the biggest exporters of carbon fiber in the coming years. Then I'm talking about the high-end automation. Yeah, this is the we have the fully automatic blade manufacturing process by using the resin inflow, right from the inflow to the valve's time when it is open, it is fully monitored by the automatic process through a PLC, whereby you will not have to look at every small elements. So this is one of the biggest advantages in the automation process. So what is India's journey in wind energy and what are the challenges ahead? We all know that until 2016, we had one of the best periods of growth in the wind energy sector. And today we have nearly 41 gigawatt installation of the wind energy. But from 2016, now if you look at it, it has drastically dropped due to various reasons. So in the COP26 summit, the commitment made by our Prime Minister was 500 gigawatt renewable energy will be installed by 2030, out of which maybe 140 or 150 gigawatt will be wind energy. Now, how do we really achieve this mega task? Because currently, if you look at our current position of the installation, and if we have to meet the real goal, nearly 18 to 20 gigawatt we have to commission every year. Are we ready for this huge task? Of course, there could be possibilities, but it all depends on a lot of changes in the policies and regulatory systems. So I will come back to that in the next slide, but I just wanted to share with you that it's time to explore the offshore wind. Again, we are at the moment in a very, very low level as far as the offshore wind is concerned. So India has a huge potential, and I read somewhere that nearly 175 gigawatt possibilities are there if India can establish the offshore wind possibilities. There is a strong integration between all stakeholders in order to achieve the common goal, which is at the moment heavily missing in India. So this is the need of the hour, that all the stakeholders should work together in order to achieve the biggest goal of 140 or 150 gigawatt by 2030. So in my opinion, these are my few recommendations to the government or the respective authorities. Number one is, it's time to introduce the repowering policy in India. We have been talking about the repowering policies for a long time now, but still there are no repowering policy. Now imagine that all the class A and B wind sites still occupied with 800 or 1 megawatt turbines. These are nearly 20 to 25 years old. So it's time to introduce the repowering policy to change this and bring the larger turbines like 5 gigawatt or 5 megawatt or 6 megawatt. So your production will be increased automatically to 4 to 5 or 5 to 6 times. And that itself will be a huge opportunity to meet the target which has been set in COP26. So question comes, now what do we do with the old turbines which are existing there? Although they are old, you can't just throw it on the ground. For that, the government should introduce a recycling policy. So ladies and gentlemen, the recycling policy, many a times I tell people that a wind turbine is like a coconut tree, nearly no waste. Everything you can use it. All the blade, nacelles, spinners, if the tower is in steel, everything is recyclable. So when you look at the composite material, there are so many projects. I'm unable to share the details with you because of some NDA, but I'm working with 2 or 3 of the German universities where a huge research and real success has been achieved by introducing some of the most interesting products which are one of its kind. So there will be a huge opportunity for the recycling business, and it can also create a lot of job opportunities for people. Then it comes to, now India, you all know very well that India is really dominated by the foreign companies in the wind turbine manufacturing. But they are all bringing the foreign direct investment, and also they are now considering, so far they are only doing export majorly from India. So this means we are still bringing a lot of forex. But the government has no consideration so far when it comes to any kind of incentives for wind industries. So this is one area I always harp on with the government, saying that when you have so much of investment, still the companies wanted to invest more and more and more in this country, but still there are no incentives or benefits, so which is a major concern for the industry as a whole. So now the solar industry has given the privilege of being in the PLI scheme, the production linked incentive scheme, but wind industry is still not part of it, which is also a concern, and I think this must be considered by the government. So, of course, both the gentlemen talk a lot about the dream of net zero carbon emission nation status by 2030. What are the steps ahead? So, implementation of the renewable energy across India through stringent policies and regulations, one India, one green energy. So if you really look at it, the domestic market or the commercial market in India, we don't have any regulatory systems in place. So this is one of the area we should really pay very strong attention, and the government must, both the central and state, to jointly take decisions that if you use the clean energy, these are the benefits you should get. I was told, I don't know exactly I'm right or wrong, but I was told somebody that in Maharashtra they have introduced the for green energy use for domestic purposes, but you have to pay, I think, 6 rupees extra or something like that. So it should be the other way, that when you use for the household purposes, when you use the renewable energy, it should be on a reduced cost. So this is something which all the government authorities, both in central and state, should work, whereby the awareness of renewable energy and the use of the renewable energy can go up drastically. Green mobility using electric or green technology source of energy, because you know that mobility industry, they are one of the biggest users of the fossil fuel, and they should compulsorily use electric or any source of green energy. This will make India much more stronger, or rather than 2070, we will be able to achieve this even in 2047 when we complete 100 years of independence. Sustainable agriculture using technology and sustainable technique of farming. This is one of the areas, especially in the farming sector, we have much more to do, because we don't use any really technological advancement or techniques for the Indian farming sector. Green buildings, infrastructure, and cities or towns by using eco-friendly construction materials, technologies, and promoting green cities and towns, providing special incentives and promotion policies. Now, I witnessed that there are houses built out of advanced composite material, which are lighter, stronger, and so many advantages you get. But still, we are so much of behind in technology when it comes to infrastructure and green building technologies. The decarbonization of energy-intensive industries. Few minutes back, Mr. Tanti said about this, and this, I think our policy makers should come forward and they should really establish policies and regulatory systems in order to people understand and use the decarbonization as an important factor of life by using the green energy. So, the biggest subject, the wind energy plus green hydrogen combination, the future is here. The future is India. I think whether it is onshore or offshore, from there with the electrolyzers, this is so much of interesting. Imagine that India, kind of a huge country, if we can use of course we don't have a heating system, but if we can use it for our domestic and commercial purposes, the green hydrogen. So this will be a huge benefit for our country to achieve net zero carbon status before 2070. So, since everybody knows that it is the green hydrogen, it is the simplest and abundantly available in the universe, is found within water and also in living elements. Hydrogen can be produced using wind energy. We do not need any greenhouse gases. Hydrogen produced using wind energy could become a key component for global zero carbon emission. So, ladies and gentlemen, the future is here. The future is India. Whether we take it as a global manufacturing hub, which we experienced, and therefore it's a great country with great potential, and India can be the lead for the green energy in the world. Thank you very much.
Thank you so much, sir, for sharing your thoughts and your experience and your insight with us. Though it is nothing big, but we like to extend our heartfelt gratitude to you. Can I take this opportunity to present a memento to you, sir? Thank you so much. We have with us the head conference, Mr. Amit Sharma. He would present the memento to Dr. P.K.C. Bose. Thank you so much, sir.
The cons and pros of both sides.
Thank you, ladies and gentlemen, for being with us for this wonderful session.